Hey guys, it's Angela Galloway again here working with STA220. Now we're in Chapter 4 talking about regression and correlation. This is a pretty important chapter. Moving on after Chapter 4, we probably won't come back to a lot of this stuff again. The linear regression kind of just stays in this chapter, and I know you also probably covered this in your college algebra class as well. But this really is an important topic because this is something that you definitely would use in real life if you're going into business or whatever degree you're going to be using. Linear regression is something that's used pretty often to forecast sales, to figure out what your inventory needs to be, to know how many nurses you need on staff. I mean, any of those kind of things are going to be figured out using regression. And then correlation we use along with regression to decide if our model is a good fit or not. So the beginning here is stuff that you've probably seen before, just talking about how we're going to um, put our data together, understanding the point slope form, all that. Now getting into our introduction to regression, the first thing you always want to do is create a scatter plot, okay? And we could do that in our calculator, so that's not something that's too difficult to do. If I bring up my calculator here, I want to go to, I got to turn it on, and then I'm going to go to Stat, Edit, go up here and clear. If you have any data, enter, and then it's going to clear out my data. I'm going to go ahead and put in this data here. So you notice that I'm going to put my X values in one column and then my Y values in the next. And we're going to talk about in a little bit how to decide which one is the X and which is the Y. For now, we are just going to assume that these are already kind of in order as the X and the Y. So we don't have to worry too much about that, but we will talk about how to do that in a second. Okay, whenever you're putting in your data for linear regression, you always want to double check that these are the same length. So you notice that I've got 14 observations here, and over here I also have 14. If you happen to type in more in your X column than your Y or vice versa, you're going to get an invalid dimension error when you try to do your linear regression on your calculator. So if you get that error, that's what it's talking about. You want to go back to your list and make sure that you have all your data in correctly. Okay, so right now I'm just wanting to do a scatter plot. So I'm going to go to second, stat plot, the same place we went for the box plot earlier in chapter 3. So I've got it turned on here. The very first one is a scatter plot. You notice it looks like a plot with little dots on it, and that's what we're going to do. Our X list, our X variable is in L1. Our Y variable is in L2. That's just going to say the mark is just how do you want the dots to be represented. And I'm going to go to graph. Okay, so you see here, you kind of see it, but I'd rather have it centered in the middle of the screen. The easiest way to do that again is to go to zoom, and number 9 is zoom stat. So we're going to do that. Oh, and that looks much better, right? So what am I looking for here? Well, what I'm looking for is if I'm trying to do linear regression, I want to make sure that my data follows a linear pattern, okay? So it doesn't have to fall exactly on a line, but it has to look like there is a linear pattern so that there is a line that I could probably draw in here and it would look like the points are falling around it. Now, if you get something that looks like a curved shape like this, or it's, squiggly all around, or it's just a big mess, doesn't really look like a linear pattern, then don't use linear regression on it. You can put whatever you want into your calculator and calculate a linear regression line. But if your data is not linear, then that line really means nothing. Okay, so the first thing you should do is look at that data. And so this is what the data look like. This is just the graph. You could also do it in Excel or whatever. So this is an Excel graph here. But once I get that data and I see that a line would fit in there, what I did was I drew in a few lines that I thought might fit this data. So I said, well, the blue line might fit, or the red line, or the green line, or of course there's an infinite number of lines I could draw in between these points. And try to figure out which line would fit best. But how do I know which of those lines actually describes the data best? And the way we're going to figure that out is using our least squares criterion. The least squares criterion, you might hear for our regression, it's sometimes called the least squares regression, and that's why it's called that, because we're using this least squares criterion. The least squares is talking about the smallest sum of squared. Okay, so the least squares is the smallest squared errors. So what the squared errors are, just really quickly, is we're just looking at the difference of each of our observations. Okay, so these were our data points. Okay, the green dots are our data points that we got from this very small data set that I'm using just as an example. The blue line here, I'm trying to see which blue line best fits these green data points. Okay, so this one here, I predicted the value to be here, right, on that blue line, but this was the actual value. So the error in my prediction is a -1. Okay, so when I subtract the actual y from the predicted y, that's what's up here, the actual y was 2. The predicted y was 3. So the error is -1 because 2 minus 3 is a -1. Then I square the errors, I add them together, and that gives me my sum of squared errors. Okay, that might be a homework problem you might run into somewhere. It might talk about the residuals. The residuals are just the differences. Okay, it's just the error. So think of residual like the residue of something. It's what's left over, right? So the residual is that leftover or the part that wasn't accounted for in that line. So that's the error we've got in there. Okay, so this is how we're actually going to come about getting that best line or the line of best fit is by finding the smallest sum of squared errors. Now, thankfully, we're not going to do this by hand because this is how it looks if you're doing it by hand, and it's pretty much a nightmare and a headache. So we really don't want to do that, but I'm just showing you that there are actual formulas here that we could calculate if we wanted to, but you're going to be doing this in your calculator or with StatCrunch, okay? Please do not try to do this by hand. Sure, go ahead and do it by hand just so you can see how they're getting the numbers, but I wouldn't go into the test trying to do it by hand just because it's so time consuming and it's really unnecessary for you to do that. So this is what it's going to look like on our calculator. So let me pull my calculator up here. I've already got my data in there. Remember we put that into our list 1 and list 2. So I'm going to do stat, calculate, and go to linear regression, which is number 4 there. In linear regression, then I'm going to put L1, comma L2, because I put in my x variable, then my y variable. Okay, so I've got L1, L2, and then I'm also going to put in my Y1. Y1 is just going to tell it what to store my data as. So I'm going to go here to variables and Y variables and function and choose Y1. Now you don't have to do this. This is optional. You can kind of see that here talking about that it's an optional step, but it can help us later on when we're solving equations because we'll already have this plugged in. And so when I want to plug in a certain X value, I can go back and use this. So I usually do that, but you don't have to. Okay, that's just an optional thing. So I'm going to push enter. Okay, and you see I get my a and my b, which is my y equals ax plus b, so that is going to be my equation. You'll notice here that I got the same answer when I did this by hand, the 1.669 and the 0.964. I got the same answer here as I did there when I did it by hand. Okay, but you notice here that I don't have the R values, right? I just have A and B. And we definitely want to get the R values because that's going to be something you will be asked about on your homework. And that's what's going to tell us if the line is a good fit or not, okay? So it's really important. So the way we get that is this little note here tells you how to do that, okay? But I'm going to show you how to do that on our calculator. You're going to go down here to catalog. So go to second 0. And we're going to go all the way down to diagnostics on. Now, for some reason, when you get a new calculator, this is not automatically pushed for you. So if you've got a newer calculator, you've never done linear regression before, then yours won't have this on. Also, once you change your batteries, you will have to reset this. So if you maybe had turned it on in Math 150, but since then you've changed your calculator batteries, you'll have to do it again too. But once you do it, it should be good until you have to uh, do your batteries again. All right, so then let's do the linear regression again. And there we go. Now I see the R squared and the R values, which are both fairly high for this data because we like R to be close to 1. And we're going to talk about that in a second. So this screen here shows you how to do that linear regression. It also references back how to do the scatter plot like we talked about already. Okay, now we're actually trying to answer questions with that data we have. So it says determine the regression equation for the data. So we did that using our calculator. So we also did it by hand, but we did it with our calculator there. So we have, you can put it in either way. You can put the AX plus B for first or the B plus AX. It doesn't really matter. It just depends on how your homework asks for it to be done. C says use the regression equation to predict sales for a new store opening that is 2,400 square feet. Okay, if you look back to the original data, the square footage was in thousands of square feet. So 2,400 square feet would actually be 2.4 thousand square feet because we're doing it in thousands of square feet. So we divide that by 1,000, get 2.4. Now, if I've already stored my equation as that y1, I can go back to variables, y variables function. I stored mine as y1, and I can put in 2.4. So that says plug in x equal to 2.4 into this equation that you saved for me. And it gets an answer of 4.972. Of course, you can also get that by just plugging it in by hand and working it out. But hey, who wants to do that by hand, right? We can go ahead and use our calculator for that if you want to do that. Okay, so that's just kind of an extra thing. So then if I wanted to know, okay, well, what if we get a store of 5,000 square feet? So I'd plug in a 5. Then I should expect sales of 9.3 million. Okay, so that can just be a quick way to plug in lots of numbers at once if you need to. Okay. All right, so how do we choose the x and the y? The response variable is going to be our y, okay? That is the variable to be measured or observed. The explanatory variable is the variable used to predict or explain the values of the response variable. So the explanatory variable explains the response variable. And notice that the explanatory variable has an x in it, right? Explanatory has x in it. So that's kind of how I tell my students to remember. The explanatory is the x, then the response is the y. Okay, so in the clothing store example that we just did, we would assume that the square footage of the store is going to explain the yearly sales, right? The bigger the store is, the more sales you'll have. Okay, the more sales you have is not going to make the store bigger, right? The bigger the store, we're thinking that's going to make the sales be bigger. So we did some examples here in my class, the number of study hours and the grade on a test. Which one do you think would be the explanatory? Well, we would guess that the number of study hours is going to explain our grade on the test, right? Or the grade on the test is going to respond to the number of study hours, okay? And so that's how you determine which is X and which is Y, because on some of your homework problems, I think you do have to identify that first before you actually calculate the regression equation. Then we've got correlation, which is our R value. Our R value, this is the formula, but again, I don't expect you to do that by hand. You should be doing that using the linear regression in your calculator. Here's some facts about R. It's going to be between -1 and 1. If it's a negative R value, then that means you had a negative slope. So that means as X increases, Y decreases. If you have a positive R value, then that means you have a positive slope. The closer it is to 1 or -1, the better the relationship is between X and Y, or the better that line is going to be at predicting values for X. It's not resistant to outliers. So just like our mean is skewed by outliers, R is as well. So is the regression equation. If you have one really high or really low value, that's going to change the entire shape or the entire direction of that line. It's going to pull the line up or down based on where that outlier is. And then the R value is going to follow that as well, because the other points aren't going to fit the line as well if you've got one really big or really small observation. So just be aware of that. And of course, it only measures linear relationships. Here's looking at some scatter plots and trying to look at what the R values would be. So you see this one is a perfect positive linear relationship, R equal to 1. All of them fall exactly on that line. This is R equal to -1. So those are kind of our two endpoints. Everything else is going to fall in between there. This one is these are more like what you would find in a real life situation, R equal to 0.9. So they're very close to a line. This is R equal to zero point 0.4. You see that linear relationship, but it's fairly weak, okay? The same thing here, but these are negative values. Now, these two both have an R value close to 0. The difference is, though, this really has no relationship, right? It's just kind of some random scatter. Sometimes X is high and Y is low. Sometimes X is low and Y is low. You just can't really tell what's going to happen. But on this one here, the R value still might be close to 0, but there is a relationship between these variables, right? You can see that there's a relationship happening. It just happens to be in more of a parabola shape, right? And not in a linear shape. So even though you may get a linear regression and an R value that's close to 0, that doesn't necessarily mean the data has no relationship with each other. It might just mean there's no linear relationship. So make sure you check that scatter plot first to know if it even makes sense to do a linear regression. Okay, so if we've got a high correlation value, so R is high, does that always mean that X caused the other to happen? These are some examples we go through in my class, just showing how just because you have a high R value doesn't necessarily mean one thing caused the other. And this is a good article website about correlation versus causation if you get some time to kind of look through that, because that's something that often the media kind of ignores. They look at a nice graph or a high R value or whatever and say, oh, that must mean this causes that, when in reality, if it wasn't done with an experiment, that R value really just shows you there's correlation between the two variables, not necessarily that one thing caused the other. R squared is something else we talk about. R and R squared are similar to sigma and sigma squared when we talked about standard deviation and variance. They really are just the square of each other. So if you have the correlation value and you're trying to find R squared, you just take R and square it. Okay, and this value is also given to you in your calculator. You notice when it comes out with the linear regression there, it gave you R squared and R. Okay, so those should both be given to you if you need them for your homework. And there's where we did a few examples of linear regression here, just plugging these numbers into our calculator and we get that outcome. Okay, now let me show you real quick how to do this on your homework. Okay, so here we have a problem in section 4.2, and it says the scatter diagram for the data set is here. So you can tell it looks linear, so we're good to do linear regression. Determine the least squares regression line. So we could do this by plugging it into our calculator. However, when the data's here, if you have a lot of data, you may not want to plug all that into your calculator, right? So push this little blue button here, open in StatCrunch. Okay, so we've got our data in there, X and Y. We're going to go to Stat and Regression, and we're just going to do simple linear regression. Okay, so it says, where is your X variable? Well, our X variable is the X, right? It's already labeled for us. Our Y variable is the Y. We don't need to do any of this. We don't need any of that. Um, you may want some of this. Really, you probably just want that fitted line plot. That's just going to show you the plot. Um, the plot of the points with the plot of the regression equation. Okay, there's all that. Okay, and that should all be fine. So compute that. Okay, so it gives us a lot of information. You're not necessarily going to need all this. Some of these things, oops, sorry. Some of these things you definitely aren't going to need for now or any of that down there. But you will want this. So the simple linear regression results, this is the important part that you're looking for. This is our regression equation, right? So it says round to 3 decimal places, so we'd only need 3 decimal places there that we'd need to round to. It tells us what our sample size is. That just kind of is a double check to make sure you put all your data in correctly. Here's our R value and the R squared. Okay, and so that's really all you need for your example. This here shows you what the data looks like. And so that might help you when you're trying to answer the second part where it says, you know, ask you about the, what's it say, graph the least squares regression line on the scatter diagram. So you might use that there, but that is what you're going to do there. So obviously not too difficult to do as long as you know where you're going. So the nice part about using the Stat Crunch is that you can go right here, click in open in Stat Crunch, and you don't have to type in anything. So you don't have to worry about the possibility of did I type everything incorrectly and all that. Now you notice there's also an option for opening in Excel. I like Excel for doing some statistical work. However, on most of your test, when you're doing it, your final exam at least, you probably won't be able to open up Excel because usually when you're taking an exam in a proctored location, they won't let you open any other program than what you have to have open for your test. So if your MyLabs is open, when you go to open Excel, that might shut down your test and cause some issues there. So it's always best just to use the StatCrunch or to use your calculator because on your final exam, you're not going to be allowed to use Excel. Okay. However, in real life, Excel is great to use, and I have lots of tutorials on that. If you have any questions about how to use Excel now or in the future, I'd be happy to help you with that. But just for this class, it's just easiest if you use the StatCrunch or your calculator, okay? So that is the end of chapter 4, doing regression. So if you have any questions, please feel free to email me and let me know, angela.galloway@kctcs.edu, and I'll try to help you out. Thanks.